All right, in this video, I'm going to talk about a heating water system. In previous videos, I talked about the heat pump loop and the cooling tower and the heat exchanger. In another video, I spoke about the DOAS rooftop units and the heat exchanger in the basement as well. This is the third system of this building, and its purpose is to provide supplemental heat in the winter months. So this is the smallest of the three. There's 5 radiant ceiling panels on this system and 3 cabinet unit heaters. So the radiant ceiling panels are in a conference room area that have a lot of glass windows. So the radiant ceiling panels are there to help for that heat loss at the windows. And the cabinet unit heaters are in the entryways to help as the doors get opened from the outdoors as supplemental heat right there to try to keep that tempered as best they can in the winter. So something to look at for these radiant ceiling panels is the detail for them. There is a schedule here. So we're looking like we have, two two-way control valves, one on the first block of 3 ceiling panels, the other for this 2 ceiling panels. So that gives the arrangement of the control valves and what that looks like. Those will get tied back into the BMS system. The cabinet unit heaters each have an aquastatin control valve at their coils as well. So for that system, we'll have 5 control valves for the controls package that we got to install. So again, this being a very small loop, not a whole lot to discuss there. I'll drop down to the pump room. So in the sub basement, we have the 2 inline pumps here. These push the supply water through the loop, and then the return comes back through. The air separator here takes the air out of the system, obviously. It has its water, domestic water makeup here, that in the event that there was a leak somewhere, this would, or an air pocket in the system, if we went and had to get access to the system to cut anything in, or there was drainage for whatever reason, that would be the fill point. Expansion tank, and then we have our heat exchanger here. So on the heat exchanger, I'll show you a few things. We have a 1/3, 2/3 control valve, which is our heat supply to this coil. So the water runs in and out of the heat exchanger, and that steam that goes to that heat exchanger heats up the water. So there are temperature sensors on the inlet side and the outlet side to monitor what incoming temperature is and outgoing temperature is, and see if we have to make any adjustments there. So the 1/3, 2/3 is set up for that. Where in minimal load, the 1/3 valve will be utilized. If the conditions are much colder, the 2/3 larger line will be open for that. So the pressure relief valve on this system is 60 psi. So something that I like to do in the beginning of the project when I draw these out is figure out what the pressure of the system will be. I guess at lowest point and highest point, but predominantly the lowest point, typically where the pumps are. So in this case, what you would want to do is look at how far vertical this system goes. So this sub basement has probably, I would say, a 10-foot ceiling. Next floor up has about an 18-foot ceiling, and then the floor up from that is probably another 18 feet. So in all, that would be like 46 feet overall. So to accommodate for that, for the gravity on that, I would probably say if we have about 46 feet there to our inline pumps, that you're somewhere around a 20 to 25 psi system. So again, the relief on that system, if it ever climbed to 60 psi, there's a relief valve that will get run to a floor drain that it would relieve itself. If well, let's see here. So the expansion tank on this, in the sense of if we're doing 25 psi, whatever that set point is, I'm gonna have that bladder of that expansion tank probably about 5 to 7 psi below that threshold. So if we're at 25 psi on this loop down in the basement, I'll put that bladder tank at probably 20 psi. Crap. All right. And then on the makeup water for that, I would probably do like 15 psi on our domestic water. So if that system got that low, that the domestic water would kick back on and fill the system back up with water. So it's a smaller system, but it's got some cool details to it. If you have any questions related to the hot water system or any hot water system, please let me know. I'd love to answer those for you. Thank you for watching.